Relative velocity. Here, coming to this topic of relative velocity, we have to know first change in velocity. What is change in velocity? So, velocity is a vector quantity. So, when we have to discuss the change in velocity topic, we have to be very clear about subtracting two vectors. Let me take here delta v is equal to delta v bar. Velocity means vector quantity. I can write it as v2 bar minus v1 bar. So from here, that is change in velocity means some v2 is some final velocity, v1 is initial velocity. Delta v bar is v2 bar minus v1 bar. Now the magnitude of this one, in from previous classes we learned that delta v magnitude means we can write v1 square plus v2 square minus 2v1 v2 cos theta. So it is very clear till here. Now this is change in velocity formula. Change in velocity formula. The main points are required is if theta is equal to 0 degree, what will happen? If theta is equal to 180 degree, what will happen? If theta is equal to 90 degree, what will happen? So you can understand that theta equal to 0 if you substitute in the above formula. Cos 0 is 1. Just I am taking this theta value as 0 and substituting here. Cos 0 is 1. Cos 0 is 1 means we'll get from mathematically we can say delta V is V1 difference V2 or V2 difference V1. That is difference we'll get. So yeah, difference in the velocities we'll get when we are taking theta as 0. If theta is equal to 180, 180 means what will happen? Cos 180 value is minus 1. Cos 180 value minus 1. So minus 1 is there means minus plus. So delta V is equal to, I can write it as V2 plus V1. And suppose theta is 90 here. If you substitute cos 90, everything will become 0. So I can write here delta V is equal to v1 square plus square root of v1 square plus v2 square. This is my formula here. So now when we are discussing about relative velocity, first change in velocity be clear, then only we can enter into the topic. Okay, you got some idea about this one. And one more point I want to give before entering into that, that is just now we wrote delta v is equal to square root of v1 square plus v2 square minus 2v1 v2 cos theta. So if I substitute, suppose if v1 and v2 both are equal to v, then what I am going to get? Direct step I am writing, I am not deriving it. Direct step I am writing, if you substitute simply in the place of v1 and v2 everywhere, I put v. Let us say I am putting it as v. Then I will get the expression as delta v is equal to 2v sine theta by 2. 2v sine of theta by 2. This is the formula I am getting. If I substitute both as v and derive, that is just a very simple derivation. We have to remember 1 minus cos theta as 2 sine square theta by 2. If you remember that point, 1 minus cos theta as 2 sine square theta by 2, you will get change in velocity formula delta v is 2v sine theta by 2 when v1 and v2 both are having same values. So both are same, then only same. How sine theta we got theta by 2 everything means calculative part I didn't write, direct step I wrote here. So nothing to worry. So yeah, otherwise we can do that one also. It is not a big issue. I'll show you that one also. So yeah, delta v is equal to square root of v square plus v square minus 2v into v cos theta we have. So delta V is equal to, I can write it as 2V square minus 2V square cos theta, and delta V is equal to, if I take 2V square common, 2V square common, I can write it as 1 minus cos theta. So mathematically we have in trigonometry 1 minus cos theta formula as 2 sine square theta by 2. From that information I can write delta V is equal to, now what I wrote, root of 2V square into 1 minus cos theta. In the place of 1 minus cos theta, I am putting 2 sin square theta by 2. So delta V is equal to square root of 2V square into 2 sin square theta by 2. So 2 into 2, 4. So square root of 4 is 2. And square root of V square is V and sin theta by 2. So this is the format of delta V when V1 and V2 are equal to V. V1 and V2 both are equal to V. We can write like that. Yeah, there are some situations like this. If theta is equal to 60 degree, what will happen? You have to remember this. If theta is equal to 120 degree, what will happen? If theta equal to 90 degree, what will happen? First of all, theta equal to 60. So if I put here theta 60, sin 60 by 2 means sin 30. Sin 30 1 by 2. 2 will be cancelled. Whenever you take theta is 60, delta V is also equal to V. And if you have taken theta equal to 120, what will happen here? This is 120 means 120 by 2 60. Sin 60 means root 3 by 2. 2 will be cancelled and we are left with delta V equal to root 3V. And here what I can write? Now delta V is equal to how much? Delta V is equal to 90, right? Here 90 by 2 sin 45. Sin 45 1 by root 2. Already 2 is there. So 2 by root 2 is root 2. So I can write it as root 2V. So these points are the basic things before entering into the topic of relative velocity. We have to know change in velocity. That is, a magnitude is change in velocity. Change in velocity. Now let us enter into the topic. Next point what we have to observe here is, that is what is exactly relative velocity means. Relative velocity is also change in velocity. We have to discuss the topic one with respect to another. Suppose I am taking V2 1 bar. This is called as actually V2 bar minus V1 bar. What is this V2 bar minus V1 bar? Why we are writing like that? This is called relative velocity of 2 with respect to 1. 2 with respect to 1. So 2 with respect to 1 means we can write like this. V2 bar minus V1 bar. That means how the V2 velocity is there, that is observed by V1. That means V2 is observed by V1. Because a person, suppose myself, I am at rest here and observing another person. So that person is moving with some velocity here. I am at rest, here my velocity is that, but he is going with 6 meter per second. So I will be thinking that what is my observation? I am observer here. He is 2. I am 1. So 2 with respect to 1. What is the velocity of this person means I can tell he is moving with 6 meter per second. Because I am at rest. Suppose myself also moving with some speed. V equal to 2 meter per second in the same direction I am moving. Then what will happen? I will not feel that the second person is moving with 6 meter per second. When I am at rest, I am feeling that his speed is 6 meter per second only. But when I am moving in the same direction of this person, then what will happen? In the speed 2 meter per second, no, if both the speeds are equal, suppose both the speeds are equal, then they will feel that they are at a rest condition like that. But now I am going with 2 meter per second, he is going with 6 meter per second. What is my feeling? What is my feeling about a person 2? What is my feeling about person 2? My feeling about person, this is not a real, this is my feeling about 2. What is my feeling about 2? Myself here. Observer is myself. My feeling about person 2 is what? Yes, my feeling about person 2 is he is moving with 6 minus 2 4 meter per second. 6 minus 2 4 meter per second. That means this is nothing but my feeling only. But really with what velocity is moving? 6 meter per second. If same person, if I am observing from rest, I observe 6 meter per second. So what I can say, when observations are done with rest means, suppose person is at rest and observing from rest, then what will happen? The speed is 6 meter per second only. But we are not at rest. He is also moving with some velocity. Then what will happen? Now what happened? Not rest. He is moving. Suppose now let us take V1 is equal to 5 meter per second. So when moving with the 5 meter per second in same direction, the feeling will be different. The feeling will be different. What is that feeling? The feeling is not 6 meter per second. That is, we feel it is 1 meter per second. The person 2 is moving 1 meter per second. That is my feeling. So to analyze this topic, that is 6 minus 5, that is nothing but 1 meter per second. Like that we can say. And second person will say back person is not moving with the 5 meter per second. Second person will not feel. How second person will feel? Is not feeling that back person is moving 5 meter per second. He is also feel 5 minus 6 minus 1, because he is also moving. No beta is moving here 5 meter per second. He is moving in the same direction of him. He feels that he is a backside, he is at a backside, and here 1 meter per second speed. Here not a question of retardation acceleration, both are moving with constant velocity, no acceleration here. Both are moving with constant velocity means we can say there is no acceleration. So with one respect to another, that means observation made with one respect to another. That is also called, what we can say means relative velocity means in one term, that is our feeling. That is our feeling. The what we feel is called as relative velocity. Here I can also write V12 bar. V12 bar is called as V1 bar minus V2 bar. Here, what is this one now? Relative velocity. Relative velocity of 1 with respect to 2. 1 with respect to 2. I want to tell one important point in relative velocity. Sometimes we'll be confused beta. That is whom we have to take first. Which vector has to be taken first, whom we have to take second, whom we have to take first, whom we have to take second. Sometimes confusion will be there in some type of questions. At that time, just remember blindly that observer is subtracted. This is a very powerful weapon which makes our work very easy. Observer vector is always subtracted. Observer is subtracted. Simply remember observer is subtracted. So whenever you are having some confusion, whom you have to take first and whom you have to say second, simply remember here V1 bar is observer minus V1 bar. Here V2 bar is observer, so minus V2 bar. That means simple line, observer is subtracted. Observer is subtracted. If you have any confusion, you can take this statement. Now, coming to this relative velocity point of view, what we can write first, V21 bar and V12 bar means we can write V21 bar is equal to minus V21 bar minus V12 bar. Why like that? Both are opposite and equal. That means A with respect to B and B with respect to A means both are things will take are having same magnitude. Magnitude is same. V21 is equal to V12. Magnitudes are same. So magnitudes are same. Magnitudes are same. directions are opposite. Direction is opposite. That is the information we have to understand for V21 bar minus V12 bar means both have same magnitude but opposite in direction. That's the main statement to be known about V12 bar and V21 bar. This is the idea about relative velocity. First of all, relative velocity means is the base information. Now we have to observe what is the next topic is about that means application part of relative velocity. For that, let us take one example. Let us take one example here. Now, suppose for example, rain is falling vertically down. This is the direction of rain. Rain is falling vertically down. And man is moving front. Man is moving front. So when we are taking such type of things, rain and man and like that, we have to be alert about observer. So in the rain and man, who is observer? Obviously, man observes rain. Man observes rain. That is the fact what we know. So simply I can write man absorbs rain means we can write this is a rain velocity and this is a man velocity. So as rain absorbs by man, we have to take VR bar minus VM bar. So what is our relative velocity formula? I told you always observer must be subtracted. Observer is subtracted. As observer must be subtracted here, what I can write here means Vm bar is subtracted. That means Vm bar, Vrm bar is equal to Vrm bar equal to Vr bar minus Vm bar. This is my formula. So here observer is subtracted. Observer is subtracted. We can also write Vrm bar is equal to Vr bar plus minus Vm bar. That means we are adding the rain velocity plus negative of man velocity, negative of man velocity. But in this direction, I have taken man velocity as positive. In this direction, man velocity I have taken as positive, and here river velocity downward like that. But here what I want, man velocity as negative I want, negative I want. That means in this direction positive means exactly opposite direction of same magnitude we can write. If you take the same length also, then I can write minus Vm bar. So minus Vm bar indicates that is opposite to plus Vm bar. Now, why we selected minus Vm bar? Because Vrm bar, relative velocity of rain with respect to man is nothing but rain velocity plus negative of Vm bar, negative of Vm bar. So here Vm bar is in this direction means exactly opposite it is minus Vm bar, minus Vm bar. So from this information, the relative velocity means Vrm bar will be in which quadrant? Vrm bar will be in which quadrant means third quadrant. Here let us, this is first quadrant, second quadrant, third and fourth. We don't get in fourth quadrant. Generally the people will think Vm bar, Vr bar is there. So we will get in this direction. Like that they will think. No, it is wrong. Because here what will happen? Vrm bar plus Vm bar will get. But we don't want Vrm bar plus Vm bar. We want Vr bar minus Vm bar. That means Vr bar plus what we have to add minus Vm bar. So that is the reason we got in this coordinate. Let us take generally what is Vrm bar? Relative velocity of rain with respect to man. The man is moving like this, rain is falling down like that. But the man feels that rain is coming in this way, rain is coming in this way towards the him. Generally, if he says suppose man is at rest, suppose man is at rest. Man is at rest. When man is at rest, what will happen? Suppose man is at rest, what will happen? If rain is falling vertically down, he feels yes, rain is falling vertically down only. But the question arises when man is moving. When man is moving. When man is moving, what will happen? Rain is falling down like that. So that when he's moving means then he don't feel the same way. He will be wet in this direction. The rain will feels rain is falling in this direction. Suppose now he has to hold the umbrella, he can keep the umbrella like this and he will be safe. But now when he's moving, if he keeps umbrella up means he will get wet. He will get wet. But when he's standing, rain is always falling vertically down only. Rain will not change its direction. Rain is falling vertically down only. But man at rest, when he's not moving at rest, he can just hold the umbrella like this I told. But the same person, when he is moving in this direction, with VM, rain is falling downward. So now if he holds the umbrella in this direction, he will get wet. Why is getting wet? The topic we are going to discuss as relative velocity. Because he feels that rain is falling. He feels that rain is not falling down now when he is in motion because his direction Vm is like this and Vr is like that. Just now I showed you that relative velocity of rain with respect to man is in this direction. This relative velocity is our feeling, what we feel, actually what we feel. VR is real velocity, and VRMR is relative velocity. Relative velocity means which we feel. So we feel rain is falling in this direction. Umbrella also has to be hold like this only. When you are moving. If you don't hold umbrella like that, you will get wet. You will get wet. So to save you from rain, in what direction umbrella has to hold, that is the concept of relative velocity of rain with respect to man. So here VR bar is coming down and VRM bar is in this direction we got. So this is what is VRM bar means, that is a relative velocity. This is the direction of umbrella to be hold. Direction of umbrella to be hold. So you have to be very clear. Direction of umbrella with respect to vertical means theta here. Here theta is angle with respect to vertical. With respect to vertical. Like that we can write. Angle with respect to vertical. Let us see what is the information we got here. So just now what I wrote is, that is nothing but VR bar in this direction, rain velocity and man velocity in this direction. And what happened? I have taken minus Vm bar in the opposite direction. What is the purpose of taking minus Vm bar means? I want Vrm bar, because Vrm bar value is what I wrote here. VR bar plus minus Vm bar in this direction. So this is theta. Theta means angle with respect to vertical. Angle with respect to vertical. This is the direction of umbrella where we have to hold. Direction of umbrella to be hold. With respect to vertical means theta. What is tan theta from the diagram? Can you say the information about tan theta? Yes. What is tan theta means? Opposite by adjacent. Opposite is what? Minus Vm bar magnitude. Don't take minus sign. Simply this magnitude. Because theta, where it cuts line, that is adjacent. Other line is opposite. This is adjacent. This is opposite. Now opposite is what? Vm. Adjacent is what? Vr. Tan theta is equal to Vm by Vr. Tan theta is equal to Vm by Vr. We got. From here, theta is equal to what should I write? Tan inverse Vm by Vr. This is with respect to vertical. Don't get confused. You have to observe. This theta is with respect to vertical only, not with respect to horizontal. Again, if I take now the magnitude. What is the magnitude means? How Vm and Vr are there? Perpendicular. I told in the relative velocity concept, if the two things are perpendicular, two velocities, there's a v1 and v2, they are perpendicular, theta equal to 90. Change in velocity, square root of v1 square plus v2 square. From that part, now I can place here what is the formula for now VRM is the magnitude. I can write both are perpendicular. So VR square plus VM square. Don't worry about negative sign. Negative sign indicates only direction. Negative sign indicates direction. So VR and VMR, how they are perpendicular? They are perpendicular. This is the direction of VR. This is the direction of VM. They are perpendicular 90-degree. So that perpendicular means relative velocity will become what? Square root of VR square plus VM square. This is the situation. I hope you got some idea about taking like that. Now, the same concept I want to discuss. I want to discuss without this V, that is a direction taking opposite and all those things, with simply with unit vectors. Simply with unit vectors. So one thing is confirmed. Rain is falling vertically down, we wrote, and man is moving towards right like this, VM bar. Let me write this direction as I assume. This is not north or east. I don't know anything. I don't know anything. This don't take it as a east or west or north, nothing. This direction which man is moving, I have wrote it as I cap. I felt like it is a x-axis. I felt like that, and this one I'm taking like this. It is like a y-axis I'm taking. Some people will can tell rain is falling from up to down. So up is positive, down is negative. So up means k cap, the z axis. That is our wish. That is our wish. Only in the situations we can take j cap or k cap, anything. That's our wish. So what I decided is this direction is x-axis. This direction is y-axis. Y-axis downward I thought. So I have kept here minus j cap. Minus j cap. So now what is Vm bar? What is Vm bar? Vm bar is nothing but Vm into I cap. Magnitude is Vm. And what is VR bar means I can write VR into minus j cap. VR is magnitude and VR bar is a vector. So why minus j cap? Because this I cap positive x axis like that I am taking. This is a negative y axis. Upward means plus j cap, downward means minus j cap. But what I want relative velocity of rain with respect to man. This is the feeling. So what we can write here means we know that man is subtracted. Why man is subtracted? Why we are subtracting man velocity? Because man is observer. Man is observing rain. So always man is subtracted. So from here, what should I write means here VRM bar is equal to what is VR bar? What is VR bar? VR into minus J cap minus VM into I cap, VM into I cap. I just substituted the VR value and VM value. You can observe VM, VR value, just I substituted here. So from here what I got here VRM bar is equal to minus VM I cap and minus VRJ cap. So now it is very easy for us. Actually, if you observe this line, I'm taking this line next page. Just observe this one. I'm taking the last line in the next page. What I wrote here, VRM bar is equal to minus VM I cap minus VR J cap. So this expression I think you can easily understand. We can write like this also. VM into minus I cap plus VR into minus J cap. If you observe this expression, VRM bar is equal to VM into I cap plus VR into minus J cap. So what I observed, negative sign. I negative, J negative. Both are negative means which quadrant? Both are negative means negative means which quadrant will get? Will get the quadrant as Third quadrant. I negative, J negative, both are negative means third quadrant. So here we can write it as simply minus I cap and this one as minus J cap. So from this we understood that is it has to belongs to third quadrant. And from this one, if a vector is a bar equal to axi cap plus ay j cap, what is tan theta means? Here, before going tan theta, what's the magnitude means? Vrm is equal to square root of Vr square plus Vm square. Because what is the formula here? A bar is equal to, I think you know this one, A bar equal to axi cap plus ay j cap. Then what is the magnitude means? Simply we'll write A is equal to square root of ax square plus ay square. Now in the same way here Vm minus I cap Vr minus j cap, minus don't worry, minus indicates only direction. So Vm I cap Vr j cap, like that it is there. So we can write square root of Vr square plus Vm square. And we want the angle with respect to vertical. Here this is suppose with respect to vertical is theta, with respect to horizontal is alpha. With respect to vertical is theta, with respect to horizontal is alpha. So remember one point, very important point here. This is theta, this is alpha. So whenever A bar is equal to ax I cap plus ay j cap, with respect to vertical means this is theta is with respect to vertical, we'll get ax by ay. Vertical means with respect to angle with respect to vertical, x component by y component. So here tan alpha means with respect to which axis? X axis with respect to horizontal. Horizontal means y component by x component. Ay by ax. So I hope you understood now how to handle this one also now. That is tan theta with respect to vertical I want. With respect to vertical I can write. What should I write? Vm by Vr. I hope you understood magnitude and direction how to handle these situations. I think this is clear to you all people now how to handle this line umbrella problem.